So there is another one different problem in partial fraction. 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. So this can be written as a by s minus 1 plus, when you have a fraction like this, s square plus 2s plus 5, you always have to write bs plus c by s square plus 2s plus 5. So this is the rule in partial fraction. If you have s square plus 1 or whatever, you should take it as bs plus c. Now you take LCM. 5s plus 3 equal to a into s square plus 2s plus 5 plus bs plus c into s minus 1. So you put s equal to 1, that is the only case. If you put s equal to 1, b will go, this whole term will go, you get the value of a. So you get a as 1. And also if you compare, because there is nothing to substitute, so you should compare coefficient of s square on both sides. So you should compare s square coefficients. So if you compare, here you don't have s square, so 0. Here you have a, s square a, bs plus c into s minus 1, so it is b. So the value of a is 1, so the value of b is minus 1. If you substitute a as 1, send it to this side, so you get b as minus 1. And again, if you compare coefficient of s on both sides, so you are comparing coefficients of s square, s constant, like that. So here coefficient of s is 5. This is done only when you cannot put values for s. And here you have 2s into a, so 2a. And here you have bs minus bs, so it is minus b, and cs plus c. So if you substitute, you get c as 2. So therefore you can find L inverse of, the value of a is 1, so 1 divided by s minus 1 plus bs plus c. So I have to separate bs, and means b into s divided by, so the value of b is minus 1, so it is L inverse of, so this is minus 1, s divided by s square plus 2s plus 5 plus c is 2, 2 divided by bs plus c, 2 divided by s square plus, so L inverse of 2 divided by s square plus 2s plus 5. This you can write directly e power t. This you have to do completing the square. Coefficient of s by 2, so it is half whole square, 1 by 4, add and subtract. So you get L inverse of s divided by s square plus 2s plus 1 by plus 1, no, coefficient of s is 2 by 2, it is 1, so you would add and subtract 1. Here also same thing, s square plus 2s plus 1 minus 1 plus 5. So basically you are getting e power t minus L inverse of s divided by s plus 1 whole square plus 2 square plus L inverse of 5 divided by s plus 1 whole square plus 2 square. So you end up with the answer as e to the power of t plus e to the power of minus t into 3 by 2 sine 2t minus e power minus t into 3 by 2 cos 2t. because when you apply completing the squares, like previous problems I did it in completing square, you add and subtract +1 and -1 and you separate, you get one cos term and one sin term, and this is sin term. So you end up with this result. So basically when the denominator is of this type, you should take terms like this as a partial fraction and you have to do the further steps.